Okay, next we're going to do some application problem for 10.4. The first one, number 4 and 5 are actually kind of review question about compound interest. So hopefully that help you review for your final exam. So number 4 say this person invests a bonus of $9,000 at 6% annual interest compounded semi-annually for 4 years. How much interest will she earn? So this is semi-annually, and she only have one big amount of money, so there's no periodic deposit or payments. So for that type, we use the regular compound several times a year formula, right? So it's going to be A equal to P 1 plus R over N and T. So that's the formula I use. Your book like this, 1 plus R over M and TM, which is kind of weird. So either way, whatever you like. It looked like my principal is going to be $9,000, right? And then the interest is 6%, which we need to convert it to decimal, 0.06. And that's going to be N is semi-annually. So it means twice a year, every 6 months. And then T is times in years, which we have 4 years, right? So using that, we can plug it in. A equal to 9,000. 1 plus 0.06 over 2 is my N. 2 times a year for 4 years, so totally they compound 8 times, right? I don't usually put in the whole thing one setting, so I'm going to do 0.06 divided by 2, which is 0.03, plus my 1 is 1.03, right? So I'm going to say this is 9,000, 1.03 raised to 8 power. So for here, I can raise it to the 8th power, and then this number, don't round it until the last step, okay? Use that decimal number times my $8,000, which we get about 11400. Because it's money, I'm going to round it to 2 decimal places, 93. So that's how much money she will have in the account in 4 years. But that's not what they asked, right? They asked how much interest she makes. So the interest is going to be the amount of money you have in the account in 4 years, 1140093. 93 cents, subtracting how much money you put in, right? So the principal was $9,000. So whatever I have in my calculator, I just need to subtract 9,000, right? The principal we put in. So she make $2,400, 93 cents for the interest, right? So that she did pretty well. So that's the interest made in 4 years. So we did that in the other exam, so hopefully you still remember something like that. That's number 4. Let's look at number 5. So number 5 say continuous compounding interest. So if you have $600 invest in an account, earn 2.75% compounded continuously. So that is the one with the PERT, right? A equal to PERT. So the last one is like compound several times a year. This one is compounded continuously. Okay, so use the PERT. How much will she make in will be in the account in 5 years? So so we know which formula to use. That would be helpful. So number 5, we will use A equal to PERT for continuous compounding. We don't know A yet. P is how much money they put in. It's just one lump sum of money, no periodic deposits. And then E is on your calculator. And what else? R is 2.75% converted to decimal number 0.0275, right? And then we also have t is 5 years. Okay, so after we have all this information, we can plug into the formula. A equal to 600, E, R is 0.0275 times T is 5 years, okay? Alright, so we're going to use our calculator. I, again, don't really like to put the whole thing at the same time, so I'm going to take care of the exponents first. 0.0275 times 5 is 0.1375, right? And then I need my E, which is on top of ln, right? So I use my second ln, get the E button. The exponents was my answer, so I can do second answer to pick up that number, right? So again, don't round until the last step. So keep that number in your calculator, multiply to my $600, right? So you will get your answer is $688.44. It's money, so we round to 2 decimal places. So this is how much money you will have in the account in 5 years. Okay, so these two questions is kind of like a review of what we have done before. The next two will be slightly different and have a little bit more new information there. So the next two is from your homework. So let's look at this together. One is number 43. They want to see Andrea plan to invest $600 in a money market account, found the interest rate. So this time we're finding the interest rate that she needs for the money to grow from $600 to $1,240 in 14 years if the interest is compounded quarterly. So again, this is compounding several times a year with one deposit only, one lump sum of money. So that's the regular compounding interest, compounded quarterly. We're going to use the A equal to P 1 plus R over N and T. So again, your book has some weird way to write that, so I'm just going to include that in case you learn it from the book. I don't want to confuse you. Okay, so we want to write down what we know. So we know both A and P this time, right? A is the amount after 14 years, which is 1,240 after you put in $600, so you more than double your money, right? And then R is interest rate, which we don't note. And then N is how many times compounding a year, which is quarterly, which is how many times? 4 times a year. And then how many years? T is 14 years. So after we know all that, we can try to plug it in and try to solve it, right? So let's try. Okay. We have 1240. P is 600. 1 plus, we don't know R. N is 4 times a year. 4 times a year is for 14 years, okay? So I'm solving for R, which means I need to simplify this side, right? To simplify this side, I can try to get rid of the 600 first. 600 is multiplying to all this, so to simplify the side with the unknown R, we will divide both sides with 600. So let me see first. 1240 divided by 600, is it a nice number? Which is not a nice number. So if it's not a nice number, we probably will just leave them in the fraction form. 1240 divided by 600. Otherwise, you will lose a lot of information if you round it at this point. Equal to 1 plus R over 4. 4 times 14 is what? 56. Okay. Alright, so again, we are solving for R. Things need to simplify on this side. Is there a way I can undo the 56 power? What is the opposite of 56 power? So hopefully you know it's going to be taking the root of 56. So that's kind of weird, right? So if it's square, take square root, right? So similar concept. we have a 56 here, so I need to take root of 56 both sides. Just let that fraction hang in there, sorry. 1240, 600, right? And these two cancel each other, so I'm gonna just leave my 56 root of 1240 over 600 here equal to 1 plus r over 4. Okay, so I'm still solving for r, right? This one need to go. So this is adding 1, so if I subtract 1 both sides, I would be okay, right? So just be careful, this 56 power of stuff and the 1 are separated, so subtract 1 is outside of the root, okay? Equal to r over 4. So almost done. The only thing is I need to get rid of the dividing by 4, so the opposite of dividing by 4 would be what? So it would be, I'm going to write this one more time, 1240, 600, subtract 1 is outside, okay? Equal to r over 4. What we need to do is we need to multiply 4 both sides. So this will cancel, right? So how do I do this? All right. If you have a graphing calculator, it would be easier. If not, 56 roots is the same as raising it to 1 over 56 power. You could do that with a scientific calculator, but I think in the class everybody have the graphing, or you have downloaded the apps to do it. So to get 56 power, you need to go to Math and number 5. Can you see there's an X there, number 5? And then you put a 56 here as your root number, and then go inside the roots, and now I need 1240 divided by 600, right? And remember, your 1 is outside of the root, so you need to use the arrow key to get it out of the root to subtract 1. Otherwise, your answer would be wrong. So as you can see, the subtracting 1 is outside of the root, right? I will hit enter first, and then I will multiply it by 4. So again, I did Math. I picked number 5, and then I did the 56 root of 1240 divided by 600 minus 1 outside, and the whole thing multiplied by 4. Okay, so that's what I did on the calculator. So I got that number, so which means that r is 0.05219 something, right? It's a very long decimal number, but remember this is interest rate, so we want to change it back to percentage, so r would be 5.22% basically. Are we okay? So this is the interest rate you're looking for. If you put in $600 and you want to get $1,240 at the quarterly compounding for 14 years, okay? All right, so again, the other way to do it, you could do like a 1240 over 600, but raise it to 1 over 56 power, subtracting 1, and then multiply by 4 if you have a scientific calculator. Let's do it. Okay, so it's going to be 1240 divided by 600, enter, raised to parenthesis 1 divided by 56, close it, and then subtracting 1, and then multiply by 4. Okay, same number. 1052219. Okay, so that's another way to input it if you don't have a graphing calculator. Okay, that's like number 43. Last questions. Number 52, radioactive decay. So suppose some kind of radioactive material decay according to these functions. How much, okay, so have to be careful. This time T is in month. So when we do the finance question, T usually is year, but this time T equal to month. We have to keep that in mind. The first one say how much will be present in 6 months. So the first one, they give you T equal to 6 months. And we don't have to convert this to year this time because T represents month, right? So cubed of T or cubed of 6 equal to 1,000 times 5 raised to negative 0.3. Need to multiply to 6 months, right? So this is just plugging into the calculator, so hopefully you can do it, but you have to be careful. I almost made a mistake earlier. Okay, so negative 0.3 times a 6, the exponents would be negative 1.8, right? So it's going to be 1,000 times 5 raised to negative 1.8. Okay, so I'm going to need to do 5 raised to negative 1.8, and this number need to multiply to 1,000, right? So it's like 55.19, something like that. So 55.19, this is in, what are we talking about? This substance is in grams. So read the question carefully. Sometimes the question may ask you to round it to whole number. But this one I'm going to round it to 2 decimal places. Okay, B is a little bit harder. B asks you how long will it take. So they want to know time is what, how many months will it take to reduce the substance to 8 grams. So they want the substance, the quantity, reduced to 8 grams. So if they give it to you like that, remember the function was Q of T equal to 1,000 times 5 raised to negative 0.3T, right? So we will replace the Q of T with 8 equal to 1,000 5 negative 0.3T. Okay. Now, I'm solving for t, right? So I need to make this sign more simple. So both sides need to divide by what? Divide by 1,000 first to both sides. So this is going to be 8 over 1,000. This divided by 1,000 is gone, right? So it'll be 5 raised to negative 0.3t, right? So I got stuck here earlier. But this chapter, they want you to solve the exponents by making both sides with the same base, right? So we're going to try. I can reduce this. This is 8 times 1 on the top. 1,000 divided by 8 is what? 125. So what I did is I divide 8 both top and bottom. Reduce it. Okay, and then equal to that. So is it possible to get both sides with same base? Look like 5 could be a good candidate. And we know 125 can be broken down into 5 times 25 and 5 times 5, right? So basically 125 is 5 to the third power. So 1 over 5 to the third power equal to 5 raised to negative 0.3t. Alright? So 1 over mean what kind of exponents? 5 raised to negative 3 power equal to 5 negative 0.3t. So when you get to here, we can cancel the base, right? So negative 3 equal to negative 0.3t. So all I need to do now is divide both sides with negative 0.3. So after we cancel that, negative 3 divided by negative 0.3 is going to be t equal to 10 months. So it takes them 10 months to reduce the radioactive material to 8 grams. Alright?